quiz is on Friday the 23rd. It's going to be f prime of x, find an f prime of x using a limit, just like, right, the last quiz. What was the last quiz? It was a polynomial and it was a radical, right? So most likely it would be a fraction, right? A derivative like 1 over x or something, right? The tangent line. I didn't grade yet, so I don't know how bad your trig was. But if it was real bad, it'll be another trig. So make sure you get if you use the unit circle, you need that on your formula sheet, right? Whatever you need, get on there, right? We're going to do a L'Hopital's rule limit, right? We're going to do some more of that today, you'll see. And then finally a continuity problem. And so the first problem we have, so that's for the quiz on Friday. So that'll be 10 quizzes already, right? So I think I could probably do 30 some quizzes this semester. And then I already promised I'll drop at least 6, right? Yeah, question? So we're going to finish chapter 2 today, 2.5. All those derivatives is 2.6 and 2.7. So just read through the examples up through chapter 2. I'm not, is there a section 2.8? I don't remember. Oh, I got the book open here. Let me see. No, so yeah, we did everything now. After today, we'll have chapter 2 done. You certainly can start, and I'll start teaching in chapter 3 today. So you can start reading ahead. But most important is that you're getting ready for this test, right? And so if you bombed a quiz, but you get that question right on the test, it will wipe out the bad quiz grade. Question and easy. Right now I have, I think, 9 set, and I have them listed for you. I'll show you that today. Yes? Absolutely. So I'm here in office hours before. So if you can get here 10 minutes before, I'll give you the extra 10 minutes to take the test. But so we start at 11 and we finish at 12:25. It should be about the same time as a quiz. So some of you still have to work on your speed a little bit, right? But let me do this problem and then I'll show you some old tests where they are and what you should practice and what you can skip, because I didn't teach one particular theorem this semester. But anyway, there's our quiz material for Friday. On Wednesday, I am reviewing. So Wednesday before the exam, I just take the whole class and just review. So, but here's our problem for, it looks like an old test, I'm not sure. So, but f of x is a 3-piece. I've got an x squared minus 4 over x minus 2. If x is less than 2, I've got an ax squared minus bx. Does it say minus bx? Plus 3 if 2 is less than or equal to x, which is less than 3. And a 2x minus a plus b if x is greater than or equal to 3. Thank you. Nice. Perfect. Yeah, so if you can, just staple next time. What's up? It's always out of 100. So I hope to give you 10 questions, 10 pages, 10 points per page. So we're trying to match this thing up in 2 places. Hey, morning. You okay? Good. So we're trying to match this. So it's really like 2 problems. We're trying to match the 2 pieces up at 2 and then match the other 2 pieces right at 3. So we got to do 2 problems here. So we're saying, well, what is f of 2? It's obviously I have to use that middle function, right? Does that make sense to everybody? So what do I get? I get 4a minus 2b plus 3. Yes, we okay there? And then we have to look at the limit of the other piece. We need the limit of, as x goes to 2, it's really from the left, of x squared minus 4 over x minus 2, right? And we got to get a replacement function there, right? So what do I get? X plus 2 times x minus 2 over that x minus 2. So I just have to plug into x plus 2, so that's a 4. So far, I get 4a minus 2b plus 3 better equal 4, right? So that's the first part of my system. I'm going to end up getting a system in a plus b. So I'm going to have to then use my Algebra 1 skills to solve that system. Elimination method, substitution method. Ms. Kerr, this making sense so far? Yes, no? Yeah, so where is the equal sign on 2? It's here, right? So I plug into that function with 2. And then I get the limit of the other one, right? Yeah. Where did the 4 come from? Yeah, so I'm plugging in the 2 into x's. So x squared is 4. There's the 4a, right? Nice. So now I got to do the same thing with the other, at the other point at 3, right? Everybody with me there? I found a connection at 2. Now I have to find a connection at 3, right? So f of 3, I use this machine. Is that clear to everybody? Because I have to use where it says x is equal to 3, right? So I get, what, 6 minus a plus b, right? I'm plugging into the x. And I need the limit on the other piece, which is as x goes to 3 from the left, and that's this function, ax squared minus bx plus 3. But that's just a polynomial, so I'm just plugging 3 into x, right? Is that making sense? So I get 9a minus 3b plus 3. So my second system is going to come from here. 6 minus a plus b equals 9a minus 3b plus 3. So I've got a system. So I have two variables, two equations. It's a system of equations, right? I'm going to simplify them a little bit. Let's see. I get 4a minus 2b equals 1. Is that okay from there? And the other one is 10a minus 4b equals 3. Right, you with me there? I just solved. I'm going to solve a system, so I want, ax plus by equals c. Right, so in this one I move the 3 to the other side. In this one I move the a, the b, and the 3. Right? Yes, Elizabeth. Because I already know that it's going to be step of 3. Remember, I want to make it continuous, right? So I already know f of 3 and the limit to the right of the same thing. So when x is 3, I'm using this bottom function, right? So when x is getting to 3 from the right, I'm using the same function. So they're going to be the same. So then all I have to do is equate that to what's happening from the left. And in that one, I'm using the middle function. Does that make sense? Remember, we're trying to make it continuous. So it's almost like when I was just saying, is it continuous? I had to find the value, then I had to find the limit left and right, and I had to make sure they matched. Now I know they're going to match. So it's a little bit less work than just showing the 3 steps of is it continuous. Abigail. Yeah, so but I have to be willing to think about what's happening, and in this case, if it's a 3-piece function, I've got 2 places to connect, right? So I'm doing one problem where they connect to 2, right? So there's my value at 2, and then there's my limit going to 2, and I want them to match up, right? Then I have to do the same idea at 3. Those are my 2 places I connect. So I find the value at 3, I find the limit as it's going to 3, and make sure they match up. Yeah. I'm assuming it's going to be continuous, and I got to find the values of the variable. What? Oh, it can be negative, but just think back to algebra 1, when we had to solve systems. Right, we had to find where 2 lines cross, remember? So we solved systems. I'm not saying you're all vampires, I'm just saying we had to find where 2 lines cross, right? So, uh, we had either substitution method or elimination method. Sound familiar to you at all? So I always like elimination method. So I'm going to multiply this first equation by -2. Right, I'm going to multiply this one by -2. So what do I get from my new system? I get -8a plus 4b equals -2. And I still have 10a minus 4b equals 3. And I'm going to add them together. Right? You remember doing this before? So I get what? 2a equals 1, so a is 1/2. So I found my value of a that will work. Now I have to find the value of b. And I can do that easily by plugging it into either equation. Right? So I'm going to use this one. So 4 times 1/2 minus 2b equals 1. So minus 2b equals -1. So b is 1/2 as well. So then I write my conclusion. With a is 1/2 and b is 1/2, the function is continuous. And then, of course, I check it on schedule. So I use this equation in green, right? And I'm just trying to get my coefficients to be opposite. If my coefficients are opposite, that variable is eliminated. So it's called the elimination. So you can do whatever you want. You can do substitution. You can solve one for A and plug it into the other for A, right? So this is like algebra 1 was running that here. But so in black, right there is my system of equations. It used to be for us x and y. Remember we were trying to find where x 2 lines cross, just to find the x coordinate and the y coordinate, they both share. So it's now A and B, who cares? But I see if I multiply by -2, I'm going to get the b variable is eliminated when I add the equation. So this is solving systems of equations from like 9th grade or earlier, right? So systems of equations. You don't always have to use a system to get a continuity problem. So sometimes they turn out to be easier. Just make sure you do all of the problems on my old quizzes and my old tests, right? Misker, that okay? Say again? I but I can multiply by anything I want to both sides of an equation, and I keep equality. Why did I choose -2? Because now I get my b variables, they're opposite. So when I add them, they go to 0. Elimination method. I'm eliminating variable b. But positive 1/2. Yeah, that's an equal sign. Right? So if this is really freaking you out, you're going to go to YouTube, Algebra 1, Solving Systems of Equations. You'll see substitution method, elimination method, and I think there's a couple on my test or quizzes that you need to do something like this. Good. Anything else you want me to do? Good. Let's take a look at the last three. I think I have 4. Yeah, Matthew. Yes. Will you got your mask? Sorry, man. I know it's a pain. Only 2 more weeks of masks, I think. So on Desmos, my first function, right, is y equals x squared minus 4 divided by x minus 2. And I want that function for x is less than 2. Believe me, putting in these piecewise things for in the TI, oh, horrible. So much easier here. My next function, I'm going to get 2 sliders from. Y equals ax squared minus bx plus 3. Yeah, and I get my 2 sliders. Oh, and that's between 2 and 3, right? It doesn't really matter about the equal sign when I'm graphing because you can't see whether it's there or not anyway. Does that make sense at all? It doesn't. I don't have to put the less than equal in because it's just not smart enough to do that anyway. Does that make sense at all? The computer doesn't have enough memory to show me if the endpoint is there or not. So there's my, right, there's the piece of that quadratic. Right, that I just want to connect to what y equals 2x minus a plus b. And that one is for x greater than 3. Is that right? Yeah. It's really, like, you understand what I'm saying? It's really greater than or equal to 3, but it's not strong enough to show me whether the endpoint is there or not, so I don't care. But you can see I'm just trying to connect, right? I'm trying to connect those little pieces there. But I already know what did I get? A is, they're both 1/2, right? So 0.5 and 0.5. And then they connect. Right? Nice. So I'm looking at our Blackboard page. And So Blackboard courses. I hate that I can't just click twice and get to our course, you know? Like, do you remember Blackboard last semester? It just gave you all your courses right away. And then, of course, we had to upgrade and pay more money, and now I have to click 7 times to get there. So Blackboard, then courses. And into the right semester. And then into our class. So I've got 4 Chapter 2 tests ready for you, right? The first one is from spring, this past spring, and it's in the announcements. I'm still working on your odd homework solutions from the publisher. It's supposed to be in Appendix J in our book. It's empty. I've asked them to send it to me. It's already been a week. I don't know what's going on, but I'll get them to you. But you know how to check everything so far. So you don't really need the answers, right? Just a little quicker if you have them. So Chapter 2 test solutions from spring 2022. The test itself is a little blurry, but if you go to the answers, it'll be cleaner. So you can see algebraic limit with L'Hopital, algebraic limit with L'Hopital, right? Tangent line, continuity, find the derivative, and number 7, don't do that because that's the one I skipped. Anything with this limit of sine x over x as x goes to 0, any question like that, just skip it. Okay? I skipped that this semester. So this is a pretty good example of what your test is going to look like. And then, of course, if you go back to past exams and etc., there's 3 more tests in there. Okay? So I'll go into Chapter 2, and I'll look at the fall 2019 exam. Yes, you with me so far here? Yeah. Thanks, Jack. So, algebraic limit, also do it with L'Hopital's. Algebraic limit with a conjugate, also do it with L'Hopital's, right? Derivative, just like our quiz on Friday. And another derivative like our quiz on Friday coming up, right? I said I'll give you a fraction one. A tangent line, it's almost the same problem, except for at pi over 6, what did I give you? 2 pi over 3? Yeah? A limit with L'Hopital's, a limit at infinity, we're doing this today. I don't usually test on that. Another one with sine x over x, don't do this one, don't bother with this one. There's a continuity, and epsilon delta I'm not asking. I haven't asked since 2019. I had so many students in tears about it, so if you want me to never test on something, cry. What's that? By the way, so in the middle, these between minus 1 and 2, give me the line, and then let x squared come off the endpoints of that segment on the left and right. Right? You can picture x squared. So cut out the piece between minus 1 and 2 and connect with a straight line. Yeah? I think that one you don't have to do as a system. You could do them all as a system, but this one is easy enough to find the endpoints. All right, so you have no homework from Monday, so you're just working on getting ready for the exam, right? I am going to be teaching Chapter 3, but it won't hurt you. It won't hurt you. It'll be good. So here's what I have for our Chapter 2 test so far. I'm thinking 2 problems with algebraic limits and verify using L'Hopital. Right? So do them algebraically, do them with L'Hopital, do them numerically with decimals or alpha fractions. Okay? That's really 4 problems. 2 derivatives using the limit. There's 6 problems. At least one continuity problem, there's 7, and one tangent line, there's 8. So right now, I only have 8 on the list in my test. If you do my old tests, you'll be ready for the test, right? So do them all. Some of you should take one and do it with time, right? Set yourself with 85 minutes, hour and 25 minutes, right, on your phone. You've got your music on, no one's going to bother you, and you see if you can get the test done, right? Because some of you are having trouble getting to a 4th problem in 40 minutes, right? So our schedule today, I'm doing 2-5 and 3-1. Wednesday I'll teach you section 2. Friday we'll finish 3-2 and then take our quiz. Monday is 3.3, that's trig derivative. None of that will hurt you for this test. In fact, it will help you. Okay? And I'll show you what I mean in a little bit. Then Wednesday before the test, we're going to review the whole class. Just going to review for the test. And then Friday is the test. Again, try and be here a little bit early. So it's 90 minutes instead of 85 minutes to do the test. And then after that, you start the chain rule. That's when the clock starts to pick up. So I need you to be caught up. I really just want you to be ready for the test. And then make sure you're caught up in chapter 2 and 3 for section 3-4. Starting the chain rule when it starts to get difficult. How we doing? We okay? Yeah, Jack. Yeah, Friday I said quiz Friday, derivative using a limit, probably with a fraction because we did a conjugate already, we did a polynomial already. Tangent line, depending on how you did on this test with the grade tomorrow. I'll do a trade or I'll do a natural log or an exponential function. But I'm going to give you the derivative in it. Right? The Bovenstof's rule limit, so it's going back to section 2. So there's just do a limit, so we have to get the height of the function, so the Bovenstof's limit, and then a continuity function. Good? Yes, we're good? Nice. So here we go. New stuff. So we're talking about section 2.5, limits involving infinity. I don't test on this often because it's too easy. I don't like giving easy problems on tests. Not likely I'll be putting this into our exam for that Friday. But we can look at a couple. So of course I want to do them numerically, right, with a table. I want to do them graphically with the, with Desmos. I can also do some of these with L'Hopital's, and then we have one other little trick that we'll take a look at. So our main theorem here is the limit as x goes to infinity of 1 over x to the n is 0. And of course we can verify this numerically and graphically. There's a epsilon delta proof, but I don't want to bother with it. So if we just look at f of x is 1 over x, right? And we're looking at this graph as x is going, as we're moving on to the right on the graph, it's pretty clear that it's going to a height of 0, right? And think about it, 1 over 100, 1 over 1,000, 1 over a billion, 1 over a godzillion, right? well, it's going to get closer and closer to 0, right? And, of course, g of x is 1 over x squared, right? Same idea, etc., etc. Yes? Still going to get a height of 0 here, right? So we're going to look at a couple of limits as x goes to infinity to see what we get. And of course, we could do them graphically, numerically, or algebraically with this particular piece, right? With this particular piece. So let's start with a nice simple one. The limit is x squared minus 4 over x squared minus 1. So in pre-cal, the way I teach this is I'm looking for the horizontal asymptote. What happens in the long run? And if I say to you x is $1 million, then I've got x squared is 1 followed by 12 zeros. So who cares about losing $4? In the long run, this thing becomes like its mother function. We become our parent, right? And so around 30. Just like my father does, my mother. Right? So this one really behaves like x squared in the long run. The downstairs really behaves like x squared. And x squared over x squared is 1. So the horizontal asymptote is 1. If we graph this, right, and we look out to that future, was it x squared minus 1, right? Oops, sorry. Right, you can kind of see, well, you can see it right away. It's 1 pretty early, isn't it? Right? It's close to 1 really pretty early. So we certainly can do that. We can do it numerically, right? So if I go to 10, to 100, to 1,000, right, to some crazy number of zeros, I get to 1 pretty quickly, yes? So you can see why I wouldn't put this on the test. It's too easy, right? But in this particular case, L'Hopital's works. So we're going to have 3 indeterminate forms. And that is 0 over 0, infinity over infinity, and infinity minus infinity. Those are our when we get answers like that, that's when we're thinking L'Hopital's. Okay? So, of course, 0 over 0 is the same as infinity over infinity. So if I do infinity over infinity, and let's take the top one to be purple, and I'm going to put that downstairs. That's become a 1 over infinity. Right, when I move something to from the numerator to the denominator, it's got to become a reciprocal. And so the downstairs one moves up. That's 1 over infinity, and of course that's 0 over 0, right? So they're the same. This one is strange, but we'll see it in a few minutes. But this one is saying infinity minus infinity is sometimes 0, sometimes it's not. So there are different sizes of infinity. Very strange idea. But the 3 mathematicians in the history of known research, they went crazy studying it. So be careful about looking at it. Different sizes of infinity. So we got our limit as x goes to infinity of x squared minus 4 over x squared minus 1 is the same as the limit as x goes to infinity of the numerator prime, right, get the derivative, over the denominator prime. Right? L'Hopital's rule. So what is that? What is that numerator? Derivative of the numerator? 2x, and what's the derivative of the denominator? 2x. So it's obviously 1. Right? Real simple, yeah? Algebraically, what we're going to do is we're going to take the highest power of the mother function in either numerator or denominator and divide every term by it. So meaning we're going to do the limit as x goes to infinity of x squared over x squared minus 4 over x squared over x squared over x squared minus 1 over x squared. Notice I divided everything by x squared, right? That's the highest power, right? That's the highest power anywhere, right? So I just take that, and so I actually divided, multiply by 1, right? You can think of that, right? So what happens now? I get 1 minus 4 over x squared and 1 minus 1 over x squared. But I know something about these two limits, don't I? I know they go to 0, right? So I get 1 minus 0 over 1 minus 0, so I get 1. All of them very easy to do. To plug in the numbers, to look at the graph, to do L'Hopital's rule, to divide by the highest power of x. Right? Pretty simple to do, yeah? Let's look at another one. How are we doing here? We okay? I really need this for chapter 5. So I don't need a test on it now because it's going to really come into play in chapter 5. So not too worried about that. Damn it. I hate the way this book works. Oh, come on. Sorry. All right, that's a little bit better. Take a look at 29. Can you see it all right? What's some other function upstairs? X. Right? Downstairs is x squared. What does that reduce to? 1 over x, right? X over x squared is 1 over x. And we know where that goes. Right? Yep. Look at 33. What's my mother function upstairs? 4x to the 4th. Right? I'm doing that in my head. Yes, 4x to the 4th. Downstairs is x to the 4th. See, I'm going to get an x squared from the first piece in 33, and x squared from the second piece. When I multiply them together, I get x to the 4th. So what's my limit going to be there? It's 4x to the 4th over x to the 4th. 4. So when the numerator dominates, right, it's going to go to infinity. When the denominator dominates, it's going to go to 0. And in between, when the numerator and denominator have the same power, right, it's going to go to some horizontal line. Do I have another one like that? I think No, next time, please. No, 26, right? X squared over X squared, yes? So that's 1. So it's going to go to either 1. It's going to go to the ratio of the coefficients. That makes sense here? What about this one? 39. Where's this going to? If x goes to infinity, what happens to this? Think of the square root function. Where's it going? Where's the square root function? To infinity. Where's 3x going if x goes to infinity? Infinity, right? So I got infinity minus infinity. So this one's trouble. So we're guessing it's 0 or something else, right? So let's take a look. This is number 2.5, number 39. I've got the limit as x goes to infinity of the square root of 9x squared, I forget already, plus x, minus 3x. So I don't know what happens there. I've got to work on this function. What do you think I should do? What's your gut say? Say it. Conjugate? Conjugate. Everyone okay here? What makes us think of conjugate? The radical, right? The square root. So I get 9x squared plus x minus 9x squared. Oh, that's nice. All over the conjugate. So the 9x's cancel, right? We okay here? What's my highest power of x anywhere? The highest power of x. Yeah, tell me the highest power of x. One, what, right? Someone might say x squared, but that's in the radical. Right, so x squared, square root of x squared is equal to x, right? So I'm going to divide everything by x. This by x, this by x, this by x, but inside it's an x squared, and this by x, but inside it's an x squared. So I'm dividing everything by a power of x. So I have x over x. I've got 9x squared over x squared plus x over x squared plus 3x over x. Is that making sense why I'm dividing by x squared inside the radical? Well, think about it. What's the square root of x squared? X. So when I pull that x squared out of the radical, it's still an x. Good. So I get 1 over the square root of 9 plus 1 over x, and then plus 3. There's my replacement function. And what happens to this 1 over x as x goes to infinity? Zero. So 1 over 6. Good? So I like those problems. I'm not going to test on it. There is one on that fall 2019 test. So you certainly can try that. It might be this problem, actually. Let me see real quick. No, What's the answer to that one there? Number 7. Answer. 2 or 3. Say it again? Yeah, sure. So it says use L'Hopital, right? So this is fall 2019, number 7. The limit as x goes to infinity of 2x squared minus 5x plus 7 over 3x squared plus 4x minus 1. Obviously, these are quadratics opening up both, right? So both are going to infinity. And they both individually look like x squared, right? Because the mother function is an x squared function. At the end, 2x squared and x squared doesn't matter. It's still infinite, right? So we're going to do this with L'Hopital's. We're going to do the limit as x goes to infinity of that numerator prime over the denominator prime. So what do I get upstairs? Ephraim, you got it? Yeah, 4x minus 5. And then downstairs is 6x plus 4. These are both linear and positive, right? Going up. So where are they going as x goes to infinity? Infinity. So I got another version of infinity over infinity. So I'm going to apply L'Hopital's rule again. So I get 4x minus 5, I'll take the derivative of that, and then 6x plus 4, take the derivative of that. What do I get? I get the limit of 4 over 6, don't I? So it's 2/3. Right? You with me there, Ephraim? Power rule, right? I've got a 2x squared. So bring down the 2 is my 4 and reduce the power by 1. The negative 5x is a linear, so what's the slope? Negative 5. 7 is a constant, what's the derivative? 0. Right, you see it? So 3x squared gives me a 6x. Right, bring down the 2, reduce the power by 1. Yeah? Okay. Yes? Yeah, Ephraim, good? Nice. Cool. So, like I said, in that textbook there, I'm not going to quiz on it, but I like problems up to 41, right? Odds up to 41. I'm working on the solutions, but of course you don't need the solutions. You can go graphical or numerical, right? Nice. We're done with chapter 2. Pretty cool. Got lots to do to get ready for the test, right? Let me peek into chapter 3 real quick. Yes. One more time. What do you do to get ready for the test? All my old tests. Every chapter 2 test you can find on that Blackboard page. Chapter 2 test. I showed you 4. right? One is in the announcements. 3 of them are in that past exams folder. One more time? Of course. Do whatever you want. So there's a fall 2019, there's a spring 2020, there's a fall 2020, right? You should look at all the quizzes, right? Let's look at spring 2020. This one I don't have a blank test, it's just, the solutions are right on it. So look at that one, factoring, right? Or L'Hopital's rule, yes, you with me? Yeah, number 1? So there it is with L'Hopital's rule. Number 2, algebraic limit with the conjugate, yes? This one works as L'Hopital's rule as well, right? Because we know what that derivative looks like, don't we? The limit as x goes to 6 of the square root of x minus 2 over 2x minus 12. So I'm claiming I get 0 over 0 here, right? I think you agree. So I'm going to do L'Hopital's rule here, right? So I'm going to take the square root of x minus 2, all minus 2 prime. I'm going to get the derivative of that. And then I'm going to get the derivative of the downstairs, 2x minus 12. Downstairs is easy, right? What do I get for my derivative downstairs? 2. Upstairs I get 1 over 2 square roots of what? X minus 2. Remember, the derivative preserves horizontal shifts. Question? No, that's, yes. But when we're doing this L'Hopital rule thing, I'm asking for quick ones, shortcuts. Yeah. So this is what? The limit as x goes to 6 of 1 over 4 square roots of x minus 2. And now I could just plug in, right? Yeah, we're okay here? Back to my exam. Yep. I can't hear you. You don't get what? Do you get the derivative of 2x minus 12 is 2? Okay, so this is a constant. The 12 is a constant. Derivative of, you have memorized, derivative of a constant is 0. Derivative of y equals mx plus b is m. So what's the slope on the line y equals 2x? 2. But we know the derivative of square root, right? 1 over 2 square root, right? And then I showed you that it didn't matter if I put a horizontal shift in it. It just took the 1 over 2 square roots and kept it shifted. Keep change flip. Keep change to multiply flip 1 over 2. So there's already a 2 in the denominator. Now there's another 2 in the denominator. So it's a 4. Yes. Keep change flip. Keep the first fraction, change to multiply, flip the second fraction. That's 8th grade. That's maybe 7th grade. 6th grade even. I don't know. When we did division, long division in 4th grade. Fractions in 5th or 6th grade, I think. Nice. Let's take a look at our shortcuts that we should know for now. So in 3.1, you're doing only shortcuts, okay? These are our shortcuts that we know right now. The derivative of a constant is 0. The derivative of a y equals mx plus 3 is 10. The derivative of x to the n, the power rule, bring down the power, reduce the power. For example, these are a bunch of power rules. Square root of x, x to the 1/2. But hopefully you set it memorized. Right? 1 over x is x to the minus first, but hopefully you set it memorized. Y is L of x, y times 1 over x, and y is d of the x, y times d of the x. This one I don't mess with. Most of the time my base is always e, but if the base, if you look at the book, the base sometimes is different. So if it's like 2 to the x, the derivative is ln of 2 times 2 to the x. Derivative of sine is cosine, derivative of cosine is negative sine. And I get that from my field, right? Moving this way. Cosine derivative goes past the negative, so negative sine. Sine derivative is cosine. So all our shortcuts right now. Yeah, where? Yeah. There's the first half. The next page, picture of this in the book, I believe it's in section 3.5, I think. It adds all the other trigs to it as well, and the inverse trigs. So you got to wait for me till we're ready for that page. What's that? I think it's 3.5 or 3.6, but you're not quite ready to copy that one down. So far, all you need is this one. Yep. Waiting just for a couple more students. Yeah, Jack.
One homework.
Yeah.
27.
Yeah. Yeah.
So the first part was like x minus 8 over x minus 8.
Exactly.
Yeah. And then the second one is c equal to like this is c equal to a. So if x equal to a.
No, not c. It's the higher c when x is there. So it's the point of a comma c. And the other one is quadratic, so it needs to be a quadratic. But you have to, there's a hole in it, right? At a. So we're trying to catch the two up. Remember, I did it on graphically on Friday. You see the quadratic moving, and you see the point moving, and then when I found that c was 2 plus 3a squared, then if the point moves, you get quadratic. But the question was what?
So when I did it on this, I think like c at 3.
Yeah, it should have been the point a comma c. So you see a single point moving, depending on where I put a, and then you'll see a quadratic moving, and I'm trying to get the point to land on the quadratic. So I'll show you that real quick. Let me show this first here. This is the second half of my shortcut derivatives. All on your formula sheet, of course, right? Yep.